Hello, and welcome to Breast Cancer Conversations, a podcast brought to you by SurvivingBreastCancer.org. I am Laura Carfing, breast cancer survivor and founder of SurvivingBreastCancer.org, a nonprofit organization providing community, education, and resources to empower those diagnosed with breast cancer and their caregivers from day one and beyond. Hello, and welcome to another episode of Breast Cancer Conversations. As always, it is my absolute pleasure to be hanging out with you today and providing you with hot topics, nascent trends, and the best conversation out there, Breast Cancer Conversations podcast. Today, I would like to introduce to you dear friends of ours, Jim Shanahan, Brad Carver, and Peter Cornelius. We met actually when I was down at the San Antonio Breast Cancer Symposium, and turns out they also live in Boston, my backyard. So, of course, we became fast and furious friends. They join us from the company Metabolic, which is just doing outstanding work in the biotech space.
Cancer is an integrated disease. It doesn't exist in a vacuum. It exists in a host, in a person. And the person's metabolic health, their psychological health, their physical health, what they eat, do they drink alcohol, are they smokers? We know that all of these external factors have a profound effect on how that cancer behaves. We have anti-angiogenic and anti-tumor activity that's known, and then we've got this anti-metabolic activity, and what direction do we go in? And that's when they said something very interesting to us. It was Dr. Dan von Hoff who recommended that we look at this intersection of cancer patients and metabolic dysfunction.
Welcome to the conversation.
Jim Shanahan, I'm the co-founder along with Brad Carver of Metabolic, and we started the company with the understanding that drug development is extremely risky, and our hypothesis was that we could de-risk drug development by starting the program off with a drug class that had proven clinical activity. So we knew it worked in people, but it had a toxicity that prevented it from moving into approval. And over time, technology gets more sophisticated. And we thought that we could apply new technology to one of these previously investigated drug classes and see if we couldn't make it more a safer drug and maintain its activity. That was the basic premise of the company way back in 2007 when we started. The drug class that we settled in on was this MET-AP2 inhibitor class, a fumagillin-based MET-AP2 inhibitor. And it had some very interesting pedigree. The drug class itself was discovered by accident by Dr. Don Ingber when he was a postdoc at Judah Folkman's lab at Children's Hospital in Boston. And Dr. Folkman, of course, was known for his angiogenesis work. He was considered the father of this notion of angiogenesis in tumors requiring blood vessels in order to nurture and feed them with oxygen and nutrients, etc.
Exactly. It is this process by which new blood vessels are formed, and it's a normal and vital part of our growth and development as humans. However, angiogenesis is this fundamental step that transitions tumors from the benign state, that is non-cancerous, to a malignant one, that is cancerous.
Dr. Folkman had that idea, and this was a sort of a happy accident, contamination in one of Don Ingber's studies, where this fungus, this fumagillin fungus, naturally occurring, contaminated one of his angiogenesis experiments, and they saw that it had very potent activity. So with that pedigree and our hypothesis that using one of these drugs, a drug from this class, could be improved upon with new technology, we set out with Metabolic. So that's sort of the general background of how we began. And then, as we like to say, a funny thing happened on the way to the clinic. We were proceeding into our cancer studies. We learned that there was this very potent anti-metabolic effect that this drug class also demonstrated clinically. So we spent some time looking at some of these activities on these using what's called diet-induced obese models, where we take normal animals, get them fat, and then we give them our drug, and we showed that repeatedly that we could reverse type 2 diabetes, at least in the animals. So this is something that had been known about the drug class. We demonstrated it with ours, and we went to our advisors and we said, all right, we have anti-angiogenic and anti-tumor activity that's known And then we've got this anti-metabolic activity, and what direction do we go in? And that's when they said something very interesting to us. It was Dr. Dan von Hoff who recommended that we look at this intersection of cancer patients and metabolic dysfunction. And at that time, we had wondered if that was a thing. And it turns out it's not only a thing, it's a big thing. And that's what we're going to talk about today.
Thank you, Jim. Great introduction. Brad, you're also a co-founder. Can we turn things over to you for a moment?
Brad Carver, co-founder of Syndevrx with Jim. I have now about 28 plus years experience in the biotech industry. Developed a cancer drug into clinical trials beginning back in 1993, and then took that drug into late stage or mid stage clinical studies. And then we started Syndevrx, as Jim mentioned, in 2007. Basically, it was trying to find a way to get a cancer drug to patients that was risk reduced. That's how the company was started.
Thank you, Brad. And Peter, if you'd like to introduce yourself.
Yeah, so my name is Peter Cornelius, and I've been with Syndevrx for about 7 years, just about the time that I think that the company was faced with this decision. My background is in biochemistry, molecular biology, and endocrinology, and my career was really spent largely at Pfizer, working on the development of new therapies to treat diabetes, obesity, and cardiovascular disease. And I'd actually heard and knew a bit about the fumagillin drug class because its anti-metabolic properties that Jim referred to were profound in animal models and in people. You know, I came into the company having a little bit of background, although kind of a newbie in terms of the oncology space. I had been aware for a long time, working in the metabolic disease space, that obesity and metabolic dysfunction were harbingers of getting cancer, that they could lead to increased risk of getting a variety of types of cancers. And that's been solidified now, and that list is more than around a dozen or a little over a dozen types of cancers. But what's new, I think, and building now is that this notion that cancer patients and cancer survivors who have metabolic dysfunction, often, again, downstream of obesity, but not always, that they may be at risk for earlier recurrence or worse outcomes.
We spoke earlier about what angiogenesis is. As we continue to define terms, can you tell me what fumagillin is and how that works?
The fumagillin drug class is unique in that it has this duality, if you will, that you don't always find in drugs being developed to treat diseases in general. Right, that it has such two fundamentally different properties. And there may be some overlap in the biology there in terms of angiogenesis in adipose tissue, for example, and how that affects metabolic dysfunction. But it's a really exciting molecule and drug class to be bringing to bear against metabolic dysfunction associated with cancer.
What was attractive to us about this class, and again, we were looking at multiple drug classes way back in the beginning, and what was particularly attractive about this fumagillin METAP2 inhibitor class was the fact it had this what's called a pleiotropic effect. It does lots of things. Its biology is not, I would say, minimal. It's got this pan activity. It affects angiogenesis. It affects tumors. It affects the tumor microenvironment. It affects inflammation. It has a profound effect on metastases. So we know that the drug class has an demonstrated anti-metastatic effect. And of course, with cancer patients, it's the metastases that you really have to watch out for. We know that pharmaceutical companies and biotech companies often have this very reductionist approach to biology. Like, it's going to reduce down to one target, one molecule, one activity, and
that's typically the mantra in drug discovery is, one mechanism, one drug, one target, and that can be successful for sure. And there's plenty of examples out there. But and often I think this pleiotropic effect of a drug is often associated with a quote dirty drug, in that it has multiple targets. And this is seen often in the central nervous system and psychiatric drugs. And that can often be a good thing in treating disease. But it can also be a bad thing in terms of side effect profiles. I just want to say that the fumagillin drug class and our compound that we're developing, the representative of that class, it has one target.
Again, to go back to these basic principles, cancer is an integrated disease. It doesn't exist in a vacuum. It exists in a host, in a person. And the person's metabolic health, their psychological health, their physical health, what they eat, do they drink alcohol, are they smokers? We know that all of these external factors have a profound effect on how that cancer behaves.
Treating cancer is complicated. If it was easy, cancer would have been cured years ago, decades ago. Given its complexity, that it takes a multi-pronged approach to really have an effect against a tumor, against its metastatic capabilities. Now that we know the complexity of it, think about the approach to treating a patient's cancer by coming at that cancer from multiple directions. So quite simply, you can treat a cancer patient and continue to treat with chemotherapy or targeted therapies. But if you add on an approach that targets directly the energy of that tumor, the glucose, the insulin, the anti-metastatic properties of that tumor, anti-angiogenesis that allows that tumor to escape and spread throughout the body. If you add these treatments together, you have and I'm talking about our drug or a MEDAP2 inhibitor, you have a much better approach or a greater chance of having an effect on that tumor and on that patient's survival, potentially. So it just makes sense when you're faced with a problem that's so complex, try to hit it from multiple directions. That's what we're doing. Our clinical trials are not to test our drug or to administer our drug at the exclusion of other therapies, but as an add-on to those other therapies.
As we talked earlier, you guys are bringing in the biotech field, the biology, the chemistry, and really approaching the science from an interdisciplinary approach, which I think is what is so exciting. We don't know what we don't know, and we keep experimenting, and we learn from that, and then we keep adding on. I hear all the time people referencing different classes of drugs. How are drugs classified? Can you explain that to me?
Well, in cancer therapy, the backbone has always been chemotherapy. Chemo is sort of like the atomic bomb, and it kills any dividing cell. And that's why the side effects can be really severe.
Yeah, hair loss.
The GI tract, diarrhea. Yeah. So that's I don't think that's going away anytime soon, with a few exceptions. The anti-hormone therapies are also, as you know, a big part of the early stages in particular. And for estrogen receptor positive cancers, ER positive breast cancers, anti-estrogen, be they direct blockers or degraders of the estrogen receptor, or inhibitors like letrozole, for example, inhibitors an enzyme that's important to produce estrogen in the body. Mm-hmm. And so, that's sort of what we would refer to as endocrine therapy. And then there's
so about the class, right? So if you're talking about a drug class, for example, in chemo, the taxanes would be considered a drug class. So paclitaxel, docetaxel, there's many more derivatives. There's pegylated taxanes now. So those or another one is albumin-bound paclitaxel, which is standard of care right now.
Yep. Okay. And so then the endocrine therapy would be considered a different class with the letrozole or the exemestane. That would be considered a different type.
So, the exemestanes, letrozoles, and, fulvestrant, they're all endocrine therapies. Then you can divide them up into, the ER degraders or selective SERDs, SERD, selective estrogen receptor degraders, or the enzyme inhibitors. Those are all endocrine therapies. And then in terms of targeted therapies, they come in a variety of flavors. If you have expression, if your cancer is labeled as HER2 positive, that receptor's presence and overexpression of the tumor provides a growth advantage, and you want to block that. And there's a therapy for that, trastuzumab.
There's Herceptin, trastuzumab is the generic name, Herceptin. But there's within that class, there are probably, I think I counted about 25 different drugs, either approved or being developed, most of which are in mid to late stage development.
Yeah.
So there's many drugs of the HER2 targeting class. And generally, that's what a class is, right? It's a target or an approach, and then lots of drugs that go after that same thing, either targeted or the hormones, for example. So that's when we say drug class, that's what we're talking about.
Does that help?
Yeah, no, absolutely. That definitely helps clarify. And then for someone who was on a lot of those taxane type of chemotherapies, as well as the Herceptin and Perjettas, and then also endocrine therapy, in my head, it makes a lot of sense. So thank you for breaking that down. And I think also for those who are even living with metastatic disease, I think that plays into, those various lines of treatment that people are on, right? So if one drug stops working, there'll be another opportunity, hopefully, that the person and the patient will be able to experience.
Yeah, and what the oncologist, when we speak to oncologists about all of this, and we talk to them pretty regularly, want to keep up with what's going on and to make sure that we've got their perspective on what we're doing and making sure that we're thinking about this right. They often tell us that their practice is that they will try and space out treatments, and they typically think about it as obviously they're going to give the most effective treatment they can, but they often think also about the side effect profile, and they save the more toxic drugs for later line therapy, which is why you'll see targeted therapies in the first line, CDK4/6 inhibitors, for example. So that's a class of drugs. Ibrance, is one. So the abemaciclib, palbociclib, Novartis is in ribociclib. Then they'll go into increasingly more toxic drugs, right? So like the mTOR inhibitors, everolimus being notable in that class. And then they'll go into the chemotherapies. Cytarabine or Xeloda is the brand name. So that is going to have an even more toxic side effect profile. But so that's kind of how they stage it.
I was on Xeloda as well. And man, I have a whole other episode on those side effects.
Did you get that hand? Did you get the red palms?
Yes, on my hands and my feet. I could barely walk, let alone type for work. Everything was so painful. But I was only on it for 6 months. So hopefully that zapped what it needed to zap. And hopefully I don't need to try that one again.
What's interesting about that particular treatment, it's one of the most commonly given drugs, these 5-FU. So that's the oral version of what's called 5-FU or 5-fluorouracil. Yeah, it gets metabolized into 5-FU in your body. Very common. We've actually done some experiments where we've shown that our drug in combination seems to work very well with.
Oh, that's really good to know.
Yeah, that was in an animal model of obesity accelerated triple negative breast cancer.
Okay. Yes, we definitely want to talk about that. One more definition and question that I have as we continue the conversation. What is metabolic dysfunction? What does that mean?
So, it can be defined in several ways based on your lipid parameters, your HDL cholesterol, your LDL cholesterol. That would be one part of metabolic dysfunction.
Like all those numbers when you go get your blood drawn.
Cholesterol levels and triglyceride levels to find out, what your risks are for cardiovascular disease, heart attacks and strokes. But we're focused, and so just when we use the term, it might include that, but we're really focused on insulin and its regulation of glucose metabolism and lipid metabolism as well. Insulin is a very, very important hormone released from the pancreas and regulates blood sugar levels. So as blood sugar levels rise above a certain threshold, your pancreas responds and secretes insulin into the body. The insulin in the bloodstream activates cell surface insulin receptors in key tissues such as the liver, muscle, skeletal muscle, and adipose tissue.
And if you have cancer, in your tumors.
Yeah. So when we talk about metabolic dysfunction, we're referring to people who've probably developed or have developed insulin resistance. So what is insulin resistance?
Well, but before we go there, let's sort of finish the definition of this metabolic health. So at the highest level, it's how your body gets its energy and processes things. So when the food gets broken down, it goes into your blood and it gets either stored as fat or burned off as energy or using muscle growth, whatever. So that's metabolism. When we talk about metabolic dysfunction, we're talking about the hormones and the mechanisms in your body that break it down and move it and store it or use it. And that gets dysregulated. And one of Peter's talking about is one of the key ways that it gets dysregulated is because of this insulin and insulin resistance. So that's what we're talking about is this sort of systemic metabolic health is how well does your body process energy? And it's at the systemic level, meaning your body, but it also applies to the cells themselves. So cells have a metabolism. Cells take in energy and processes that energy. And how they do that is can also get very dysregulated. So you can think about it both at the systemic, the person level, and then you can think about it at the cellular level. And what's interesting in cancer is both are dysregulated. So all of these things are metabolic driven. But at the cell level itself and in tumor cells, they are also dysregulated. And it was a guy named Otto Warburg, who was a very interesting character about 100 years ago, discovered this, what's called the Warburg effect, which is that tumors like to take in sugar and they break it down very quickly. And rather than go through what the cellular process is supposed to be, which is a complicated set of steps to maximize the amount of energy for the cell, the Warburg effect is that it just breaks the sugar apart and immediately uses it and then spits out what's called lactic acid. And so you get this dysregulated metabolism at the cellular level, and then that leads to dysregulated metabolic at the systemic level.
If I could just add, we just focused on insulin as one of the primary metabolic hormones that we're targeting in these cancer patients, but there are two others that are pretty important as well, and they're adipose or fat-derived hormones. And one of them is leptin, and the other one is adiponectin. And there's been a ton of studies published on the importance of these two hormones as well in having an effect on the tumor's growth and the outcome of that patient if these hormones are dysregulated.
Yeah.
So, and our drug happens to, by inhibiting METAP2, we have shown in our phase 1 clinical study that we have a dramatic effect on the insulin levels, on the leptin levels, and on the adiponectin levels. All three primary metabolic hormones that you want to have an effect on.
You know, when we were designing the phase 1 trial, it wasn't designed to focus on metabolic dysfunction. You know, phase 1 studies are safety studies. And of course, we try to gather additional evidence that the drug is doing what you expect it to do. And it was pretty surprising when I was looking at the insulin data and I was looking at it. And, you know, the clinical data can, you know, on small trials can be pretty messy hard to understand. But I realized that if you focus on the patients who only had the high levels at baseline, they all went down. Patients who had normal insulin levels pretty much stayed the same. So when we talk about metabolic dysfunction, we're talking about it in terms of, you know, insulin resistance leading to hyperinsulinemia, which has a negative effect on tumor growth. It stimulates tumor growth, as Jim was talking about, and also dysregulated fat tissue derived hormones, leptin and adiponectin. And I just want to say a little bit more about adiponectin because it's been known for a long time, and I've been familiar with adiponectin.
Well, you were around at the discovery of
the initial cloning and discovery of the adiponectin gene was conducted as part of a collaboration between Pfizer in Connecticut, where I was at the time, and involved in our group as well, and MIT and in Harvey Lodish's lab. And that resulted in the cloning. And nobody knew what it did or what it was. Just called it ACRP30, which was a adipocyte complement-related protein of 30 kilodaltons. So they just called it ACRP30. I had no idea what it does. And I've actually stayed in touch with the guy from Harvey's lab. He's now a very, very prominent scientist at UT Southwestern in Dallas, Philip Shearer. And Philip is a great guy, and he's really exposed the fact that I'm going to get back to this. The adiponectin is insulin sensitizing. Mm-hmm. So not only does adiponectin can act on tumor cells directly and dampen tumor growth, but it has a profound insulin sensitizing effect, a good effect on the body, on the liver in particular, helping the liver manage blood glucose. and by sensitizing it to its own.
So I wanted to go back to a couple things. I wanted to circle back to the Zolota thing because one of our advisors is Dr. Joyce O'Shaughnessy. Her patients, when they're on Zolota, because they get the soreness on their hands and feet, very common side effect, that they tend to become more sedate, right? Or they don't move as much. And because they're not moving around as much, they start to gain weight. And weight gain leads to a whole cascade of bad effects for their cancer. And so she likes to present herself. So she's very strict with her ladies about maintaining their weight, maintaining a healthy weight. But so, Laura, what was your experience? Did you find that happened?
Not everyone on Zolota develops this hand-foot syndrome. However, I was one of the lucky ones, and I know so many of us who are listening to are like, oh yes, if there's a side effect, count me in, I'll probably get it. But it was almost impossible to exercise. My feet just killed me. I could barely walk from the bedroom to the couch, let alone the couch to the kitchen, to the dining room table. Every single step hurt. So yes, it was impossible to exercise, honestly. And then, of course, you can say, well, I'll just focus on the nutrition side of things and eat well or limit the amount of calories I take in. But you're going through cancer treatment. I mean, that's probably the last thing on my mind, honestly. You'll probably hate me saying this, but I was probably one of those patients where it was like, oh my gosh, cake? Of course. Like, I already got cancer. How bad could this be for me? So, yeah, it was really just day by day, getting through day by day and fighting the cancer, saving my energy, embracing the fatigue, and exercising when I was able to, but not forcing myself to, and really just being kind to myself.
Wow. Yeah.
So the side effects of the therapy are kind of inducing metabolic dysfunction and having a negative effect. And then there's also treatments, treatment-caused metabolic dysfunction.
Yeah, exactly. And that's something that I think we should get into now, because that's very much as I don't know who said it earlier, that I think Brad, you said it. The drug we're developing is not intended to be mono used alone. It's intended to be used in combination with other therapies, and that could include, as we talked about chemotherapies, we talked about endocrine therapies, and we talked about targeted therapies, and it could be used in combination with any one of those classes. And as Brad was starting out to say, that these drugs, for a variety of reasons, can actually cause metabolic dysfunction and lead to weight gain, which leads to metabolic dysfunction, or in some cases cause it directly.
Yep.
Right. So if you think about that treatment paradigm, if you will, if our drug is on board, and this is the hypothesis, if our drug is on board in combination with the chemotherapy or the targeted therapy, number one, we think that you may get a greater effect from that therapy, because we're minimizing the negative effects, we believe, that are caused by that therapy. So that therapy will work better. It'll do a better job that it was designed to do. And then you add on top of that the benefits of our drug by inhibiting METAP2 and all the anti-metastatic, the anti-angiogenic, and the correcting the metabolic dysfunction, improving insulin sensitivity, dropping insulin levels, dropping leptin levels, increasing adiponectin levels. Put all that together, and we believe we're going to provide a better outcome for these patients.
This is just a win on so many levels. I am so excited about how much information I learned in 30 minutes of just connecting with all three of you. Brad, Peter, and Jim, thank you so much. I'm going to give our listeners a little bit of a reprieve so they can soak in all of this rich and amazing information that you shared with us. And we will continue the conversation next week, where we talk further about metabolic health and the role it plays in our cancer care. Thank you again for being such great partners and joining us on today's podcast. And thank you all for listening and tuning in week after week here on Breast Cancer Conversations. Please be mindful that all of our content and information is for educational purposes only and is never a substitute for medical advice. If you want to hang out, again, please check out survivingbreastcancer.org/events, where you can RSVP to our Thursday Night Thrivers weekly meetup, our Movement Monday classes, workshops, seminars, and so much more. We can also continue the dialogue online via social media. Our Instagram handle is survivingbreastcancer.org, all one word, and you can follow us on Twitter at SBC_ORG. Until next time, keep on thriving.